Okay, so in today's video, we're going to go over the basics of the distributive property. The distributive property is something you're going to use a lot in algebra 1, algebra 2, integrated math 1, integrated math 2, math 3, and even geometry. So here's how the distributive property works. The distributive property is when you have a number or a value outside of the parentheses. Like right here, I have a 5 outside the parentheses and a 4 plus 3 on the inside. All right. Now, normally, if you follow the order of operations, you can easily solve this. You always start off with trying to solve what's on the inside of the parentheses. So what's on the inside of the parentheses? 4 plus 3 becomes 7. I have 5 on the outside. 5 times 7 is 35. We have just simplified this expression. Now, that's using the order of operations. We can also, although we don't recommend it, if we can actually solve what's on the inside of the parentheses, we can use the distributive property. The distributive property is, should have been a plus in there. Same expression, except now we're going to take what's on the outside and distribute it to what's on the inside. Fix this, there we go. So this really says 5 times whatever's on the inside. All we're going to do is take and multiply 5 times the first term on the inside and take 5 and multiply it times the second term. So 5 times 4 is 20. 5 times 3 is 15. Once again, we're adding them together, and we still get 35. So either way, you're going to get 35, whether you follow the order of operations or you use the distributive property. Now, why would you actually use this? Why wouldn't you just keep it simple with the order of operations? Because sometimes you're not going to be able to combine what's on the inside of the parentheses. They might be two different terms. So, here we have two different expressions where on the inside, we can't combine them. I have a 4 and a 3 just like last time, but now it's a 4x plus 3. I can't combine those because this one doesn't have a variable with it, so I can't combine 4x plus 3. I can't combine them. So to solve this, I would use the distributive property to simplify it. So I would take the number on the outside, multiply it times 4x, and also multiply it times a positive 3. So if I have 5 times 4x, 5 times 4 is 20. And then I have my x. I have 1x, so I bring the x down. Now I do the same thing for the second term on the inside. 5 times 3 would be 15. And it's a positive 15. So now we've actually simplified the original expression. We can't go any farther because, once again, I can't combine like terms. One has a variable, the other doesn't. So at this point, we're finished. So this will be our final answer. All right, let's try this one. The cool part about it is if you're actually watching this video and you want to kind of test yourself out on what we just learned, hit pause and try to answer this one on your piece of paper or in your notes, and then finally hit play and see what the actual answer is. All right, so this one we've solved the same way because I can't combine x plus 2. Just can't do it. So we're going to take 4, or negative 4 rather, multiply it by the first term, but then also multiply it by the second term. Negative 4 times x, or like the ninja one, there's 1x there. So negative 4 times 1 is a negative 4. We bring down our x. That's our first term. And then negative 4 times a positive 2 would be a negative 8. So we have simplified the expression using the distributive property. All right, so far so good. Let's add a little more to it. So here, we now have a variable on the inside and a variable on the outside. for both of these. So once again, we're just going to multiply whatever's on the outside, the term that's on the outside, by each individual terms on the inside. We're going to distribute to the first term, and then distribute to the second term. Now, to solve this is really like saying 3x times 1x. Okay? So when you multiply something that have variables and numbers, you multiply the coefficients first. 3 times 1 would be 3. And then you multiply the variables second. X times x would be x squared. So 3 times x is 3x squared. Now we multiply 3x times 4. And we multiply the coefficients first. 3 times 4 is 12. And we only have one little x. We are adding it, so we can still add them together. And we now have a more simplified answer. And we've gotten rid of the parentheses. All right, let's do this one. Change colors. Change it up a little bit. All right, same rules apply here. We're going to take whatever's on the outside and multiply it by both terms on the inside separately. So once again, as we learned over here, we multiply the coefficients first. That's the numbers in front of the variable. So that would be 6, and x times x is x squared. And then 2 times negative 2 would be a negative 4. I only have the one little x over here. So that would be my final answer if I was simplifying that term. All right, so far so good? Excellent. All right, one more screen. We're going to put yes, I said a fraction out in front. All right, here we go. Same rules apply. We're going to take whatever's on the outside and multiply by each individual term on the inside. They're actually not that scary. So, we have a fraction here. Is 6x a fraction? No. Can we make it a fraction? Yeah, we just put whatever the term it is over 1, and we turn it into a fraction. Now it makes it easier to actually solve. Because we multiply fractions, we just multiply across the top and across the bottom. So x times 6x would be like saying 1 times 6. Because remember, there's a little 1 in front of that. The ninja 1. It's like it's there, but you can't see it. And now we give me 6x squared. Because remember, there's x times x gives you x squared. And then 3 times 1 would be 3 on the bottom. All right? Now, let's do that. There we go. It's fixed it. And now we're going to multiply x over 3 times 3. So 1 times 3 would be 3x. Remember, we're adding these together, because that's the sign in the middle. And then 3 times 1 would be a 3 on the bottom. So 1 times 3 is 3. 3 times 1 is still 3. Now we can simplify it one step further. We look at our coefficients. Does the number in the denominator go evenly into 6? Yes, it does. 6 divided by 3 gives me 2. I got to bring down my x squared, because I only worked with the coefficients here. I didn't do anything with the variables. Plus 3 goes into 3 one time. I bring down the x. And once again, I don't really need that 1 there. We can erase the ninja 1. And that is our final answer. That is simplifying the term above. All right, let's work on this one. All right, same rules apply. Whatever's on the outside, we're going to multiply by each individual term on the inside. And we're going to multiply like fractions again. So 3 times 4 would be 12. X times x is x squared. 4 times the 1 that would normally be underneath of here would just be 4. That's our first term. We're going to add this together. Now we do the second term. So remember, we multiply the coefficients first. That's the numbers in front of the variables. So 3 times 12 is 36. Now, wait a minute. We have an x and a y. We can't get x squared from that. We can't get y squared from that. So we're just going to put x and y together. X and y. Because really we're multiplying x times y. When anything is side by side, it means we multiply them together. So we don't know what the numbers are going to be yet for x and y, but we do know we have to multiply them together. So this is 3x times 12y is 36xy. We do the bottom, 4 times 1 is 4. All right? Now, just like we simplified over here, by looking at our coefficients, we're going to see if we can simplify the coefficients here and here. And we're in luck. 4 goes into 12 evenly 3 times. This 12 divided by 4 is 3. And then I just leave my x squared, because I didn't do anything with the x squared yet. And then we're going to add 36 divided by 4 is 9xy. All right. That, if you're in my class, that should be able to help you out with some of your classwork or practice work for today. If you have any questions, please ask me in class. If I do post this on YouTube, give me a little like down below, or a comment if you have any questions or like to see any other videos you might possibly want to see me do on math. All right. Have a good day.